Good job, you've made it to the end of this tutorial. We've seen that in today's AI world, modern AI models like deep learning models don't come with a lot of built-in assumptions about the data. This is what we mean by weak inductive biases. Traditional models like linear regression assume things like the relationship between variables is always linear. But modern models prefer to learn directly from large amounts of data without making these kinds of assumptions. Because they rely on big data sets, these models can pick up on really complex patterns. But the catch is they might also get too good at the specific data they were trained on, and not do so well with new unseen data. This is where we need to reintroduce some biases through data augmentation. Data augmentation is basically about tweaking the training data in various ways to create new, different versions of the same data. For example, in image processing, you might rotate, scale, crop, or flip images. This tricks the model into learning important features that stay consistent despite these changes. As a result, the model gets better at recognizing patterns and generalizes better to new data. Another key point is making sure the training data is diverse and covers lots of different scenarios. If the training data is varied enough, the model learns to handle different kinds of inputs, which makes it more robust and effective in real-world situations. To sum it up, modern AI models work well with lots of data and fewer built-in assumptions. But by using data augmentation and ensuring a diverse dataset, we help these models generalize better and perform well across a range of real-world scenarios.